Cloud computing is a key focus of the class this semester. So what is cloud computing? Well, oftentimes we'll start out by trying to define cloud computing, and oftentimes people look to NIST for that definition. NIST is the National Institute of Standards and Technology, and they defined cloud computing over a decade ago. Their cloud computing definition still remains the sort of standard definition used in the marketplace. And I'm not going to read this definition word for word, but you'll notice that I've highlighted several of the terms in the definition, terms like on-demand network access and a shared pool of configurable computing resources, and the ability to rapidly provision and release resources. So let's take a closer look at some of those aspects of cloud computing. Generally, we talk about sort of 5 different characteristics of cloud computing. Cloud computing is available on demand. We can provision infrastructure when we need it, typically via some sort of self-service interface. Cloud computing resources are available via a network. These are internet-based resources oftentimes, or sometimes if we deploy these resources within an on-premise data center, we can access sort of a private cloud. We generally share resources in a cloud computing environment. So resources are pooled together and aggregated. And when you provision resources within a cloud, you're essentially partitioning part of the resource pool for your own usage. But the key point is that you're sharing compute and storage and networking resources with other customers in the cloud. The cloud is elastic, and elasticity is one of the key benefits of cloud computing. It's just this ability to rapidly provision more resources when necessary, and then more importantly, we have the ability to deprovision those resources when they're no longer needed. And that's very different than the old days of computing, where you would buy physical servers from companies like Dell, HP, and IBM, and then you install your application and services on those servers. And if you no longer needed a service, then you had to try to figure out some other use for that computing capacity. Whereas in the cloud, you just simply give the computing capacity back to the cloud provider. If you buy a physical server, you can't just like a year or two later tell Dell that you want to send the server back to them. It just simply doesn't work that way. And then finally, cloud computing is a utility-based service. So from a pricing standpoint, it's a pay-for-usage pricing model. Just like when you're buying electricity from the power company, you only pay for the amount of power that you need. The same is true with the cloud, where you're purchasing resources and you're paying for computing capacity on a per second basis, at least with AWS. And if you're not using the compute capacity, you're just simply not paying for it. So I already talked about a number of the characteristics of cloud computing. And so in terms of the benefits, well, the biggest benefit is the fact that cloud computing resources are elastic, and it's easier to align cloud computing infrastructure capacity with the current demands on your IT organization. Traditionally, when you would buy infrastructure, you would buy a bunch of servers, and then you'd have a set amount of computing capacity that would meet your needs. And as your organization grows, at some point you need to buy another bunch of servers, and so it's just sort of this step stair acquisition model where you are, you are buying infrastructure, in these sort of big chunks over time as your business needs grow. Well, the problem with that stair-step approach to infrastructure acquisition is that at different points in time in your business life cycle, you're going to either have more computing capacity than you need or less computing capacity than you need. And each scenario poses some problems, right? If you have more computing capacity than you actually need, then that sort of represents an opportunity cost. Instead of buying more servers, maybe you could have invested more money in your sales and marketing efforts. On the other hand, if you don't have enough computing capacity to support your business, then you're probably introducing some delays, some friction in your business processes, and making the business slower and less efficient. And of course, that presents a problem as well. With cloud computing, the idea is that you should always be able to provision just the right amount of infrastructure to support your business needs at any given point in time. So that's the real promise of cloud computing, along with the elasticity, the ability to rapidly provision infrastructure is also a huge benefit. Years and years ago, when you're buying servers, it literally could take weeks or months to integrate new servers into your computing environment. With the cloud and the fact that just about everything is completely automated, it means that we can introduce new compute capacity literally within seconds in some cases. Now, the cloud computing lends itself to a couple different service models that we find in the marketplace. And there are really three main service models that you'll find today. The first is what we call infrastructure as a service, or IaaS. With infrastructure as a service, the cloud provider is delivering a security hardened data center. They're providing the networking. They're providing the physical compute and storage resources. And you, as the customer, are responsible for managing an operating system that lives on those servers and then the applications that run on top of the operating system. With platform as a service, or PaaS, the cloud provider is delivering the data center, network, the physical servers and storage, and they are also managing an operating system layer. As a customer, then purchasing services from a PaaS provider, as a customer, you are focused on building application software. So you're writing application code and leveraging some sort of API that is being exposed by the cloud provider. And then finally, software as a service, or SaaS, means that the cloud provider is delivering everything that the infrastructure as a service and platform as a service provider is delivering. In addition, the SaaS provider is also providing the actual application. So they've written the application code, and as a customer, you are just simply taking your data and pushing it into that application, and you're consuming that application generally via the internet. And then finally, in terms of deploying cloud resources, there are sort of three different cloud deployment models that you'll find in the marketplace. The most prominent one is what we call the public cloud, and that's the one that we'll be using extensively in this course. The public cloud means that there's a cloud provider like Amazon or Azure or Google. They've built the data centers, they're providing the infrastructure, and everything is available via the internet. On the opposite end of the spectrum, you'll find private clouds. What a private cloud means is that you have an organization that has the wherewithal to build and operate their own data centers, and the organization populates those data centers with computing and storage and network infrastructure, and then they deploy applications and services across that infrastructure using some sort of cloud-like technology. And there are a number of different technologies in the marketplace, things like OpenStack, which allow you to sort of automate the provisioning of your privately owned infrastructure. So that's what we call private cloud. And then finally, we have this notion of hybrid cloud. And what hybrid cloud means is that it's an organization that is essentially tied a public cloud environment to a private cloud environment. For example, the organization might deploy customer-facing services in the public cloud, and those customer-facing services may interact with back-end services, maybe like a back-end database system that lives within a private cloud environment. So they've sort of integrated the two infrastructures together to form a hybrid cloud.